Welcome back, learners. Now, to consolidate everything that we went through throughout this lesson, we're just going to do a quick recap. And we started by looking at the main idea whereby we're introducing the concept of force, and within that, we started by looking at what is this force that you're actually talking about, how do we measure this force, and what are the effects of this force. We further went on to look at the forces that are always working in pairs. We also now looked at the balanced and the unbalanced forces, the difference between the two. That for the balanced forces, their forces are going to be acting in opposite direction, but they're going to be equal in magnitude. Now, when that happens, there is no noticeable change that is going to be seen on the object that those forces were applied to. Now, with the unbalanced forces, we're saying that one force is going to be greater than the other. If object A exerts a greater force than object B, then we're going to see a noticeable change in either the direction or the speed of the object and even the shape of that object, because those two forces are not going to be balancing each other. And when that happens, those forces are not going to be at equilibrium. Now again, in the lesson we used words such as force, equilibrium, and resultant, whereby now we said force is either a push or pull, and then equilibrium, that's now a state in which opposing forces are balanced. And then the resultant, that's now the total amount of force acting on an object or body along the direction of the body. So what I want you to always remember about this lesson, what I want you to take away from this lesson is the following things. That number one, forces are invisible. We can only see their effect. So we can't see the actual force, but then we can see that a force was applied here by looking at the direction at which the object will take, or the shape of the object, if it is going to be deformed or not, and even the speed, if the speed of the object is going to increase or decrease, or even come to a standstill. Number two, what we need to take away from this lesson is that a force is a push or pull, or even a twist that is exerted upon an object. And then number three, that a force has a size and direction. Very much important that when we denote a force, we are using an arrow, and then the length of the arrow is going to show the size, and then the arrowhead is going to show the direction of the force. In this case, our force is going to the right-hand side. But should our arrowhead be facing the opposite direction, then we are saying that the force is exerted onto the left-hand side. So we draw an arrow on paper to represent a force. As you have said, the length of the arrow determines the size of an arrow, then the arrowhead determines the direction of the force. So if more than one force is exerted on an object, the forces combined to deliver a net or a resultant force. As we have said, remember, forces are working in pairs or always acting in pairs. So if the two forces are balancing each other out, that means the resultant is going to be zero. However, should the forces be exerted onto an object and those forces are different in terms of the magnitude, if force A is greater than force B, that then means the direction that is going to be taken by the object in which those two forces are applied will be determined by the greater force. So if the greater force was exerted to the right-hand side, then the object is going to go to the right-hand side with the resultant force. Then multiple forces can simultaneously be exerted on a single object. As we have said, we can have more than one force exerted onto one object. And we said now, when we are adding all those forces exerted onto that object, we are coming up with something called either the net force or the resultant force. And that resultant force is going to determine the direction of that object in which it will be taking. However, should those forces, those number of forces acted or exerted onto that object be equal in magnitude, balancing each other out, then that object will be not going anywhere. Remember, the forces are going to be in equilibrium, or they're going to be balancing each other out. Now, with all of that said, I have just one last question for you. And that question is, I want you to give me the examples of contact forces. So what are examples of contact forces? You're going to answer this question for me, and I will see you next time. Until then, bye.